Hello everyone, welcome back. Here's VanAmsen, and today we have an interesting data structure on table the tree, also known as prefix tree. If you ever wonder how autocomplete feature or spell check work, well, you are in the right place. So smash the like button and let's get dive. So what's a tree? It's a tree-like data structure that store a dynamic set of string which is super useful for quickly retrieving and storing words. So we will implement a tree class with three main methods: insert, add, a word to the tree, search checks if a word is in a tree, and starts with checks if any word is in the tree starts with a given prefix. So first, let's create a helper class called tree node. So this class will represent individual nodes in our tree. So let's implement it. So class tree node and div init self and self children and self is end of the word false. Okay, so we have implemented it, and children, a dictionary where key are a character and the values are tree node object, and is end of the word a boolean flag to indicate if this node marks the end of the word. So now let's initialize our tree with a root node. So self root will be tree node. So init function done, and time to add words to our tree. So well, we will start at the root and move down the tree, creating new nodes if necessary. So let's implement it as well. So node self root, and for C in word, if C not in node child, node child, tree node, and node will be node children. See, and node is end of word will be true. Okay, so now let's implement our search method to find a word that exists in our tree as well. So node self root for C in word, and if C not in node children, return false, and node will be node children, and return node is end of word flag. Okay, so yeah, let's make spaces, maybe here one. Okay, so we implemented search as well. So yeah, the last part is to implement starts with methods. So lastly, this is super useful for features like autocomplete. So let's implement it as well. So node will be self root, and for C in prefix, if ch not in node children, return false, and node children ch, and return true. Okay, so this is a whole implementation. We can run it to verify it's working. Yeah, so all good. And So it's classic implementation of prefix tree. So let's submit it also for unsyntax cases to verify everything's good. So yeah, all good, and we beat 56% with respect to runtime, and also 74 with respect to memory. So if you want to implement it in other programming languages like Go, Rust, C++, and more, check the link in the description below. And that's it for today. I hope you enjoyed this deep dive into trees. And if you have any question or suggestion for future video, leave the comment below, and don't forget to like, share, and subscribe. And that's wrap up. So keep practicing, stay motivated, happy coding, and see you next time.